Hello, my name is Cynthia Sanchez, a member of the EPC team at Ashcroft. In this video, I'll be speaking with Dave DeLugo, the product leader for Ashcroft Temperature Products. In a previous video, Dave provided a quick overview of the RTDs and thermocouples, including how they work and when to use them. Today, Dave will take us through the ordering process of an Ashcroft S81 RTD and remote transmitter. It will cover both the ordering requirement of the instrument and a step-by-step example of how to build the part numbers for the Thermocouple, RTD, and transmitter. Welcome, Dave.
Happy to be here. I hope I can simplify what many people think is a complicated process.
To start, let's review the ordering requirements. What do people need to know about the physical, environmental, and certification requirements of the RTD before placing an order?
For the physical requirements, the first thing you need to do is determine how the sensor will be mounted into the thermowell, the insertion length of the thermowell, and the diameter of the probe. The insert nominal length, which is labeled L, is measured from the base of the transition piece to the tip of the probe, or from the spring-loaded fitting to the tip of the probe. The cable length, LC, is measured from the top of the transition piece to the end of the extension wire cable. The LC length and the L length are then added to the end of the product code in millimeters. Inches are converted to millimeters by multiplying by 25.4. Environmental factors will be based on the location of your application. It'll typically fall into one of two categories, hazardous or non-hazardous. A hazardous location is an area where there is a threat of a fire or explosion because there are flammable substances present. These locations are commonly found in oil and gas, chemical processing, pharmaceuticals, and mining. Once you know the location type, you'll be ready to select the sensing element, which can be a single or dual RTD. If a remote head is needed, you can select from the range of available head types that will perform best in your application. A transmitter can be mounted in the remote head. Now you need to select the extension wire type and insulation. There are also options for flex armor or connectors that may be required. If needed, the required agency approval will be based on the area classification and method of protection. And a 3 or 5 point calibration certificate may also be required.
Okay, Dave, now that we know the ordering requirements, can you show us how to build the actual part numbers for these products?
Yes, we will use an ISA-style data sheet, which describes the application to define the probe, transmitter, and thermowell needed. So we're going to look at the general section first for the requirements of the area classification. This is a non-hazardous area requirement. Then we're going to look at the process section, and we're going to look at the temperature and pressure ratings just to make sure there's anything of concern. Now we're going to look at the temperature element section, and we see that this is a RTD probe, 100 ohms, 3 wires. It's a 1/4 inch diameter. The length is fit to thermowell. The element connection is going to be a 1/2 inch NPT. The sheath material is going to be 316. It's going to be a single. Accuracy is going to be Class A. It's going to have an extension cable insulation of PTFE, 36 inches long with stripped ends, and it's going to have optional flex armor. The process connection is going to be a 1/2 inch NPT by 1/2 inch NPT spring-loaded nipple. Now we're going to look at the transmitter requirements. This is a remote mount transmitter. It's going to have heart and an indicating display. It'll be loop powered, and it's going to have a range of 0 to 200 degrees F. Now we will look at the thermowell requirements. It's going to be a threaded 3/4 inch thermowell, tapered. It's going to be either 304 or 316 stainless steel. We're going to select 316 stainless steel. It has a U dimension of 10.5 inches and a overall length of 12.25 inches. There is a requirement for a tag. Now we're ready to build the thermowell part number, the first of 3 part numbers that I will be walking you through today. We've reviewed the ISA data sheet, so we know that the requirement is a 3/4 inch NPT tapered threaded thermowell. It has a U dimension of 10.5 inches and an overall length of 12.25 inches. We look at the Ashcroft data sheet for the threaded thermowell, and we come up with a part number of 75W10502HT260 S2XNHW5. Now we're going to determine the L and LC lengths for the RTD probe. The L is equal to the S dimension, which is equal to 12 or 305 millimeters. The LC dimension is for 36 inches for the cable length, which is 915 millimeters.
Great, Dave. Once you have the Thermowell part number, now it's time to build the RTD and transmitter part numbers, correct?
That's right. The RTD part number will be the second part number that is needed. There are 22 steps. Let's go through each one now. The part number starts with the model type, which is S81. For the location, the area classification was non-hazardous, so that we're going to select 1, standard general purpose. For the sheath diameter, the requirement was 1/4 inch. We're going to select code T for 1/4 inch. The RTD resistance, we saw from the requirement it being a PT100, so 100 ohms. So we're going to select code 1 for PT100. The accuracy requirement was class A, so we're going to select code A. The calibration range was 0 to 200F, so we are going to select the code A thin film RTD. The wiring configuration, the requirement was for 3-wire, so we're going to select code B for a single 3-wire RTD. Sheath material requirement is for 316 stainless steel. We're going to select code A. For wire termination, it was stripped ends, so we're going to select code 7. For the connector strain relief, there was no requirement, so we're going to select dash. For the head type, there is a requirement here. This is going to be a remote head with the transmitter with display. For this, we're going to select code P, the PR7501. This section is for probe length. In the code, we're going to put X, and the length, L equals 305 millimeters, will be put at the end of the code. For the cable length, we're also going to put an X in the code, and we're going to put the LC equal to 915 millimeters at the end of the code. For cable protection, there was an option here for flex armor, so we're going to select code 1 with flex armor. The requirement for the lead wire jacket was PTFE, so we're going to select the letter O. The lead wire options, there were no requirements for this, so we're going to select a dash. For the process connection, the requirement was for a 1/2 inch by 1/2 inch spring-loaded fitting, so we're going to select Y1. In the other features category, there were no other features, so we're going to select 3, none. In the certification section, it was the non-hazardous area, so there is no requirement, so we're going to select a dash. For calibration certificate, there was no requirement, so we select a dash dash. There was a requirement for a tag, so we're going to select code T. At the end of the product code, we're going to put LC equals 915 and L equals 305. The final product code is displayed on the screen.
Wow, that is a lot of steps. But having you walk us through each step helps simplify the process. Are we done?
Not quite. As the final step, we need to build the transmitter part number. Let me take you through that now. So we're going to once again review the ISA style datasheet specifications, and we saw that it was a remote mount transmitter heart with indicating display. So for that, we're going to look at the Ashcroft transmitter datasheet, and we're going to select the transmitter, the PR7501A. It's going to be programmed with 1 sensor input, the sensor type being an RTD 3-wire. It's going to have an error signal of the 22 high alarm. The 4 milliamp value is going to be 0 degrees F, and the 20 milliamp value is going to be 200 degrees F. To build the part number, again referring to the Ashcroft transmitter datasheet, it starts with 7501A, then there's a dash, and P1, then 3, then 22, then 4 equals 0, F, 20 equals 200F. The final 3 part numbers needed for this application are shown on the screen. One for the probe, one for the transmitter, and one for the thermal well.
Thank you, Dave. This has been very helpful. Is there anything else you would like to add?
Just a reminder that Ashcroft also offers additional videos for RTDs and thermocouples that may be of interest to our viewers.
For more information, visit ashcroft.com.